Good afternoon, everybody. I hope everybody can hear me. There's still people coming into the meeting, so we're just going to give another few minutes before we start the meeting. In the meantime, I want to say once again, welcome. Welcome to the second series of free webinars that we will be presenting. My name is Hannes Otto. I'm manager for the Didactic Training and Consulting Department in South Africa. And this is new for all of us. So this has pushed us into a new way of presenting, a new way of teaching, a new way of conveying information to you as customers. And I'm sure that in future we will run these type of courses parallel to our normal face-to-face training courses. This is the free webinars, so limited time, obviously, so with limited information that we will be sharing, but we want you guys, the purpose of this is for you to take something out of it, not to feel that you've wasted your time, but that you really take something from this, and that we can show you what we are capable of through these webinars. From next week on, we will be running our 4-day webinars. That will be 2 hours per day for 4 days, session 1, session 2, 3, and 4. The complete courses will consist of all 4 of those sessions, where you will be doing your practical training or the practical portion of the webinar on FluidSim, which is a very powerful piece of software. We will also be showing you how FluidSim works, so you can do design and simulation on FluidSim. So like I say, with the webinars that we will be starting next week, we've got our basic pneumatics, basic hydraulics, PLC, FluidSim, and connecting Festo equipment to Siemens as well as electro-pneumatic courses that we will be running. So those courses will be, you will get the FluidSim software and you will physically be doing your practicals on those courses. So without further ado, I'm going to give over to Charles. Once again, thank you very much for participating. There will be a short poll at the end of the webinar, so please just complete the poll. As you might know, we do have the other free webinars also from tomorrow onwards until Friday. And if you've got any questions, you're more than welcome to contact me. You can post a question in the chat tab. So please enjoy. Thank you very much, Charles.
Okay, good afternoon, everybody. In other countries, maybe good morning. Thank you for joining us at Festo, the free basic pneumatic presentation course that we're going to do today. And remember as well that this is like an introduction to the technology. We obviously cannot tell you everything we know about pneumatics in the next hour and a half. It is as there are too much information to actually convey to you, to make sure that you actually grow in using the technology and understanding it properly. So we would urge you to actually come for the basic pneumatic course so that you can actually spend more time with us and that we can show you all the information that we can squeeze into these hours that we are together. And normally the courses are usually 24 hours long, so it's 8 hours over 3 days. And that means that's still just the basics that we're actually showing you, that we are telling you, and are teaching you to actually understand. So there's actually a lot of information we want to transfer and to convey to you. But I think we're going to kick off with some of the basics just to get you going and just to help you to understand the technology and where pneumatics come from and what we actually do with pneumatics. So I would like to actually quickly try to play a video to you guys, because there are some guys that are not in industry, they are not with a company that uses pneumatics at the present, and I just want to play a video just to see, to give those guys a chance to actually recognize where pneumatics are being used, and also where you can actually use it and what it's meant to do. Okay, so I just want to quickly get a video here. Since the video closed, okay, let me get another video quickly. Okay, so if I look at this video, I'm going to show you a video. There we go. Okay, I'm going to play this video just to help you guys to see the video properly. Make sure that you do not have any webcams on at the moment. It's just going to increase your speed of the video that you can follow properly. Okay, Davi or anyone just give me some heads up that you can see my screen, my video.
We can see
your screen and your video.
Okay, thank you. Okay, so here we go. I'm going to play. Just have a look. I just want to start from the beginning. There we go. Here we go. Is the audio okay?
Yes, the audio is excellent, Sean.
Thank you.
What does automatic packaging machine and this lock have in common? Let's take a look. Huge forces are required to open and close the lock gates. Force is required in two directions. Hydraulic drive is the right solution. The lock gates and the control room are far apart. This means that control signals have to be transmitted over a large distance. But a hydraulic pipe is not suitable for this. Electrical control signals, which travel via electrical cables, are the right solution here. In the case of these complex automatic assembly machines, it is not distance that is the primary argument against pneumatic control of the valves. In this case, it is the many control functions required in order for the entire complex program to execute. Here, too, electricity has been selected for signal transmission because it is simply more manageable. And because electricity is a prerequisite for the use of electronic open and closed loop control systems. And it allows a system to be linked to the company's data processing system. In that case, why use pneumatics at all, if electricity is there anyway? Well, pneumatics drives allow linear motion to be achieved much more simply. And fast cylinder speeds can be achieved, resulting in short cycle times. In these examples, the control energy is not the same as the work energy. That is why they are called electro-pneumatics and electro-hydraulics. These are so-called hybrid systems.
Okay, so that was just a video to get you guys to understand actually where pneumatics are being used. So it's in industry, it is to automate your machinery and to make money for the companies, because a company exists to make money and to help the community. So basically what we're going to do is I'm going to show you quickly a slideshow, and we're going to go through some of the basics that you guys need to know as you guys are just being introduced to the pneumatics. Okay, so having a look at the next part, the next slide of the slideshow, we can see air generation distribution. So there's always a lot of factors that needs to be considered when actually designing your systems and when installing your systems. Okay, like there's a few that you can see there at the moment, like storage requirements of the air cleanliness, as there are many different types of levels of air cleanliness. And it depends on your environment and the type of factory that you are in, and that determines the requirements for the cleanliness. It depends whether it's a pharmaceutical company or whether it is a FMCG or if it's another type of company. So it depends on what the cleanliness of the air should be, depending on it depends on the environment that you are in and that you're working in. Okay, so this is just a few of them. There's a lot more considerations or factors to consider when actually looking at air distribution and air generation. And for that, usually you would need to have a system installed. And in that system, mostly throughout all the factories, you would see something similar to this. So these are basically mainly all the components that you should find at your factory. and that it should be installed that actually would allow your pneumatic system to actually operate properly. Okay, so pneumatics by itself, if we just look at pneumatics and we think about pneumatics, we are actually using compressed air to do work. Okay, so we are compressing the air, and that compressed air we use to perform work, and to do it actually at quite high speeds. So if we quickly have a look at all the components that you should have in your factory, and you should be able to find it somewhere if you have a pneumatic system at your factory or your workplace, then you should find a compressor somewhere, which is the compressor number 1 here. And there you can actually see in this component, what we're doing is we are compressing the air. So from here, obviously, because the pressure went up, the temperature went up, and therefore, if we go to number 2, we can see we have a number 2, which is the cooler, and therefore we need to cool our air. Okay, there's also something called the dew point that we need to maintain, and when you actually do our maintenance course, we talk more about the dew point and the limitations that you also need to consider. Okay, then we also have number 3 here. You can see it's a condensate separator, but it's not just in this position. You can see it's all over in the system, and you can find it in the various points and various places, depending on how your circuit is built and how it runs throughout your factory. Okay, so a condensate separator is actually the component that separates all the condensation that develops because of your air being heated up and cooled down. And as the temperature rises and falls, so there's condensation that develops in your system, and condensation is our worst enemy in pneumatics. So we need to make sure that we eliminate all condensation as far as possible and as much as possible, as it causes a lot of rust and other problems to occur, like the swelling of all your seals in your cylinders and so forth. Okay, then we also have a number 4 here, which is the receiver. The receiver is like a pneumatic battery, which is a place where we can store our energy so that you can use it as you go along. There's also a lot of other purposes connected to the receiver, which we would also go into more detail once you do the basic pneumatic course, or if you do the maintenance course, the base maintenance pneumatics course. Then we also have number 6, 9, 10, and 11. You can see they all look kind of similar, but they have different names. So there's a pre-filter. Number 9, 10, and 11 is a different classes of filters. Okay, so the filters we will just have a look at quickly as well today, shortly. And you will see that there are differences between them, and that depends on the class of air, the cleanliness of the air that you actually need from your system. Because, like I said, for pharmaceutical, we might need a lot more cleaner air than in a normal factory environment where it's just a workshop, for instance. Okay, so then we also have, so that is actually covers number 6, 9, 10, and 11. Then we also have number 7 here, which is a dryer. And the dryer, usually, if you look at the air, there's 2 things we need to maintain with the air. We need to make sure it is clean and dry. So the dryer is obviously the one component you need to make sure that you do not have wet air. You actually do not have moist air. You have dry air going to your components. Like we know, the condensation is our worst enemy. And then usually on a dryer that you would also find is on a number 8, which is an electronic purger, because the dryer will take up all the moisture, and then that moisture should be blown off back to tank or to the point of exhaust, and then to your drain. And then that is number 8. That is actually our electronic purger. Then we already had to look at number 9, 10, and 11, which is different classes of filters. So you start large, you go smaller and smaller and smaller with your filters, but we will have a look at that shortly. And then you also should have a water and oil separator. Not all factories have them, but it should be used because of the environmental impact that your company could cause. Okay, then obviously, then also if you look at your circuitry of your piping systems, then you would see that you also should have a loop at the top. Okay, but that's more on the maintenance side and the installation side of things. I'm not going to stick with that today too much, so we will move to the next slide. And if you look at the next slide.
Sorry, Charles.
Yes, Hannes.
I see there's Evelyn has got his hand up. Evelyn, I'm going to unmute you. If you've got a question, just please post your question.
Yes, guys, you can please ask questions if you have any questions in between or you want to know something. Yes, Evelyn? Okay, Hannes, I'm not
Evelyn?
receiving any.
Okay,
Hello?
no, I'm not receiving any sound as well. Evelyn, you're
Okay.
more than welcome to type in the question or in the chat box, then we can just attend to your question.
Okay, fantastic. Okay, so I'm going to continue. Evelyn, just leave it in the chat and we will talk about it as we go, or as soon as I have your question. Okay, then we also have different types of compressors, and then you can also see there are different types of compressors, which we have the positive displacement compressors, and then we also have dynamic types. Now, for the pneumatic types, we usually want to use the positive displacement to ensure that we have a constant flow of air. And so that if a compressor is rated at 100 liters per minute, then we're going to make sure that it delivers 100 liters per minute, because in a factory environment, you do not want any fluctuations on your lines, as that can cause delays in timing and also on your speed. It could play a big role if more than one cylinder moves together at the same time. So we need to maintain the pressure, that it stays constant, and then the fluctuations are as little or as few as possible. So those are usually the positive displacement compressors that you would use, and you would connect it into your system, and mostly the factories would also make use of it. Okay, so the conditioning of compressed air, like I said, there are different classes of air that you need to know about. Actually, if you do our maintenance course, then you would learn more about that. But for each class of air, there are different types of filters available and different types of airflows that also need to be maintained, also depending on what type of machinery you are running. Okay, and if you look at the conditioning of compressed air, there are a few things that you need to remember. So if you look at this, it's a shocker for most people. If you look at 1 meter by 1 meter, 1 meter of air, which is a cube of air, it contains 180 million dust particles. So our air is really not good, it is not clean, and therefore we need to clean it so that we can get clean air into our systems and our systems last long. Okay, then you can also see that at 50 degrees Celsius, on average, you would find 50 grams of water in the air, and then obviously also some oil, which is quite, not a good thing as well. And then there's obviously other things that, because we drive cars and trucks and too much transport in the world. So there's a lot of other things as well in the air that can be found. But 180 million dust particles is a big shocker for most people. And to get rid of that, to ensure that you have clean air entering into your system, to make sure it lasts long, is a big thing. Okay, so there are 4 things that you need to look at. The first thing is the correct pressure, and the correct pressure means also there's a few other factors that you need to consider. The correct pressure might not be the highest pressure. It should be the lowest pressure, but that your cylinders still move at a constant rate and without causing any problems on the line. So the correct pressure is, there's a few questions you need to ask yourself. How low can the pressure be so that your system still functions properly and at the normal speeds that it should function at, without reducing the speed. As most people would also tell you, pneumatics are meant for speed. If you use hydraulics, it's meant for power or force. Okay, so in this case, we want to make sure we ensure speed is maintained so that we can make a lot of products in a short amount of time. Then you can also see that there's condensation is another problem, and which we also spoken about already. And the constant condensation separators that I showed you in the system in the previous slides. So that is a big problem as well. And then also, if we look at the third one here, less particles. Like I said, 180 million dust particles in each cube of air is a lot of dirt. And then lastly, we also need the correct oil. There's a certain type of oil that you need to use, and also we do a lot of that we talk about a lot of that also when you're doing the pneumatic maintenance course. Okay, so if you just have a look at some of these problems that we might occur, and if we have an incorrect pressure, you can see that early wearing of equipment, high operation costs, and high operation comes because your pressure is maybe too high, so your compressor is working harder, it draws more power so that it can actually overcome and keep the higher pressure up. So at the lower pressure, your compressor would work less. So that means lower costs, operation costs, if you have the correct pressure. Then we also can look at more particles in the system may result in pressure drops, blocked lines, and malfunctions of the system. So dirt particles is just as bad as any condensation that you might have in your system. If you look at the other two, which is the next one, the condensation, you can see the corrosion is a big problem and lower velocity. So like I said, pneumatics is meant for speed. So you need to maintain the speed of your system. And if you have condensation, you will definitely bring it down. The speed will drop over time. And then obviously the last thing is the incorrect oil. If you use the incorrect oil, like I already mentioned earlier on, water and oil can cause seals to swell or start to make to cause it to crack and that type of thing. So there's a lot of problems that these four things can actually create in your system, and we need to make sure that it is properly cleaned and that it's dry when it enters your system. Okay, so going to just the next slide here, you can see just a few examples of some of the poor air preparation results that you can see that we just taken some photos of, and we just illustrating here. This is the inside of the valve. You can see the rust actually has been developed. And then this is the spool on the one of the valves on the inside. We will talk about that a little bit later as well. And then some of the filter inserts here you can see was also bad. So it's very, very bad. Poor air preparation is going to cause a lot of problems for your system and for yourself and the maintenance team overall. So we need to make sure we look after our equipment, and we need to make sure we remove those four things. There you can see it. So the pressure should be correct. The particles as low. You only need to allow the number of particles which is correct for your class of air, and then also you need to make sure you remove all the condensation, and then lastly to make sure you do not oil your system unless it should be oiled. And there are certain rules that you need to keep to and stick to make sure that you only add oil into the system when it is necessary. So, but we also do that in our basic pneumatic course. So this is a air service unit. Now I would actually like to show you also these parts in practice so that you can just not just see some photos, but you actually see it for real. Okay, so here's our air service unit. It's usually made up out of a couple of components. The first thing on the left hand side, you can see there's a filter, and then to remove condensation. So for our filter and our dust condensation, I'm going to bring in another camera just to show you our unit so that you can see. And then also the second thing we have here is a pressure regulator. Okay, in this case, it's a three-way pressure regulator with a gauge. There's our gauge as well. And then thirdly, we have the lubricator, which is going to be used for lubricating the system. We put all of these together and we combine them, and then it forms one unit, one complete unit like this. So if we had to add these up, we put them all into a little square, and there's our new symbol. So this tells us the filter, the pressure regulator and gauge, and then the lubricator. So there we go. Those are some of the components that you would see in pneumatics. If I can quickly show you my screen here. There we go. Okay, so this is just a practical, actual component here. So this is our on-off valve that we have on this side. Here's our pressure gauge. Here's our pressure regulator at the top. There's a pressure switch. In this case, we have some extra units here with a branching module, and then we also have a filter at the bottom here. Okay, so in here we will replace the filter insert. This side we also have a silencer. So this is basically an air service unit that you would see in the field. Okay, fantastic. So let's have a look at some of the details about some of these components that's actually being used in these air service units. We go to the first one, the adjustment of pressure. This is very important. Two questions you should be asking is, what is the correct pressure for the system? Like I already said, the lowest pressure that you can operate smoothly at, that is the correct pressure. The second thing also to look at is the correct flow. So you need to make sure that the size of your regulator is correct and that the flow rate is correct, that it will actually allow it to pass through to the system. Remember, if the flow rate is too low, then your cylinders would have problems if more than a certain amount of cylinders start to move at the same time. We do not want to have that problem. We also need to make sure that we have a constant flow all the time to our system. So we need to, these are the two main questions you need to ask when installing your pressure regulator or doing the settings. Okay, here's just some of the examples of what they look like in action in industry. Okay, just different types, and so you can see they all look different. Okay, then the next thing I would like to show you is some of the filters that we can actually find in industry. So these are the four filters, the four main filters that you will see in industry from number 1 year to up to number 4 year. The sterile filters, they are very small. They are used for bacteria and viruses, as you can see, and that's actually a whole new industry by itself, just to work on with these filters. But for pneumatics, basically, you usually would start with a 40 microns, then you would go to a 5 or a 1 micron, and then you would go to microfilter, and then the active carbon. So you start on the left-hand side, and you work your way downwards as you move through your system to get to your through your distribution system to get to your actual working components and your system of where your valves are being used. Okay, so usually also this is usually on the 40 microns. And then this is the 5 to 1 micron. This is a 0.01 micron, and then this is very small. This is much smaller. And I usually make some jokes about it and say, if you have a factory that makes chips and flavorings, and it has an odor, and your employees start to eat your food, and they eat the profits, then you need to add some active carbon filters to make sure they do not get hungry while they are working on your components. Okay, but just to make it a bit more practical, I want to show you some filter inserts that we would have here. Okay, here's one of them. Okay, this is the active carbon filter. Let me just get it in. Here we go. This is the active carbon filter. So this is actually the one in the back here on the right-hand side. Here we go. This is the active carbon filter that we have here. Okay, then we also have a look at another one. Let me just close it a bit here. Here we go. Okay, here's another one. This is a fine filter. This is a fine filter that you see here. Okay, that is a fine filter. So here we go. If on the bottom, you will also usually be able to see the size. In this case, this is a 1 micron. It's written there at the bottom. Okay, you cannot see the camera. It's a bit dark here at this point. Okay, but it's 1 microns. It stays there, and this is your fine filter. Okay, then we also have a micro filter. It looks a bit the same, but if you actually hold it in front of you, you would see there is more porous. This one, this filter insert, it's more porous, and this is actually the micro filter. Okay, there we go. And yes, this is just some examples of the filter inserts that you can see. Okay, if you have a look at the next slide. And like I said, also, we only have an hour and a half here to talk, so we can't tell you all the ins and outs. We would like to spend more time with you to actually show you everything inside out. Okay, so when to change a filter? This is usually a good question that we find in industry, and as most people should know, but they don't always know, you should actually install some indicator for pressure drop. If there's a pressure drop over your filter line, it means your filter is blocked. So if you have a high pressure coming in and a lower pressure leaving the filter, then you actually have a problem. Then you need to start replacing your filter insert. Otherwise, your filter insert will become more blocked and clogged, and that will cause more problems downstream in the system. Okay, then we also have the lubricator. Okay, so like I already said, there's a certain type of oil that you're going to use in a lubricator. And if we look here, this is a hydraulic oil with that viscosity. You can write it down now if you need to. If you don't know, please write it down. It's 32 millimeters squares per second. And so that is the thickness of the oil. So the oil viscosity should not be anything else but that. So please make sure your oiling is done correct with the correct oil. Also, the other thing I also mentioned earlier on was that you need to make sure that when you're oiling, you're doing it at the correct time. Okay, and then for the correct reasons. Please remember that most of the valves that you are buying these days, they are already pre-lubricated by the manufacturer, so you do not have to lubricate unless you meet certain conditions. Then you would need to add a lubricator as well. But to do that, actually, I would recommend that you actually, before you do that, you get one of our sales engineers just to come and help you and to have a look at your system and to make sure that you actually need to lubricate your system. Otherwise, if you start lubricating, you will have to keep lubricating it yourself. Okay, fantastic. This is just to show you where you can actually adjust your oiling system. Okay, there you can see there's a plus on that side, minus this side. There's the way the oil will drop in. Okay, this is a chamber, and yeah, this is just to show you the lubricator from the top. Fantastic. Then you also have something called on-off valves. You get different types of on-off valves. In this case, they are showing you the 3-2-way, the normally closed 3-2-way. So it's a valve that you need to open and close your system as it goes. Okay, so it is open and close your system. And why you want to close, you'll be able to close your system. The line to your system, going to your system, is to actually make sure that the system becomes safe for the maintenance crew to work on it, and to actually also to exhaust all the air in that line going to your system. So that for that reason, we would use a 3-2-way normally closed valve. Okay, so this is an on-off valves that you would usually find in factories if they want to isolate their machines from the main line. Okay, then just some tubing and fittings. I'm not going to talk a lot about this, but just to show you some things. Okay, so most of the tubing damage, it has you can see only 10% comes from mechanical damage. The rest is because you use the wrong tubing in the incorrect environments. Okay, and there's also other things that I just added here just to talk to you about is reducing the leakages. Make sure you also have a look at all of these things, all of these places here. You can see the fittings, the quick connectors, couplings, hoses, tubes, pipe joints, seals of cylinders, seals of valves, air service units, and condensation traps. Okay, so all of these things they have place. There's a chance where the leakages can take place, and there is always a certain amount of leakage that does take place. Okay, but to make sure you reduce leakages, the amount of leakages is a very good idea, because you would increase profitability of the company. Okay, and then there's obviously different ways to actually detect your leaks. Okay, in this case, this is the easiest and the cheapest way to detect leaks is to use a soap solution. You just spray it on, and you can see where the bubbles come up or start to show, and then you know there is a leak. Okay, so that is for detecting leaks, just to show you and give you some ideas. Okay, and then this is now one of the things that we actually took a photo of one of the connections that some employees of a certain company had done, that connected to a valve. And as you can see, if you look here, if the air passes through the valve, it goes back and it exhausts to air. So it means we are just wasting air. Then there's also many of you guys, or you know someone that does things like this. This is the incorrect way. Please do not do this. I know there's some guys chuckling now because they might have been part of this problem. Okay, so always remember to reduce the leakage. We do not want leaks in our factories. We want to make sure that we maintain a proper flow, proper pressure, everything, and without any leaks. The more leaks you have, the less profitable your system becomes. Okay, fantastic. So let's have a look at some of the symbols, because we will be designing and showing you some components today as well, in this within the next hour or so. And so you need to know some of the symbology. Okay, so let's have a look at the first things that you need to know about is the relationship. That there's a relationship that exists between pressure, volume, and temperature, and there's also a relationship that exists between force, pressure, and area. Okay, so the first thing for volume and pressure, I would like to play something, a small simulation I have here. Here we go. Okay, so pressure and volume. So you can see the pressure is at the moment low, and we have maximum volume. Okay, so but as I bring this piston down, I'm going to start to put pressure on the container. I'm going to build pressure inside the container, and then there will be a pressure being developed. So let's quickly have a look. So there we go. So pressure and volume, they work together. Okay, so the first one, we have 1 liter, 1 bar being applied to 1 liter of volume. So you can see the pressure is at the moment it's a 0. Okay, so now let's halve the volume. So there's a volume now, half a liter, and you can see the pressure doubled. Okay, so you can see at half liter, the pressure doubled. If we do it again, and we halve the volume again, Now it's 1/4 of a liter, and we can see it's 4 bar. So you can see that the pressure went up proportionally as the volume decreased. So this is one of the main things that you need to remember, one of the main principles of pneumatics. And remember, we're using it to do work. Okay, but this is important to remember when you actually work with pneumatics, as this can cause some problems if you do not maintain this relationship. Okay, let me quickly show you another one as well. Another simulation. We look here. Okay, so in other words, if we look at the second one, just going back to this one, if we look at the relationship between force, pressure, and area, to create a force, we need to apply pressure to an area. Okay, so if we apply pressure to an area, then we will have a force, and a force can actually perform work. Okay, so in other words, if we look at the size of a cylinder, the larger the cylinder is, the more force we would have. Okay, so here's a small cylinder, here's a larger cylinder, and then a very large cylinder. So you can see you will see that the force goes up more and the larger the cylinder becomes and is. You can see on the first cylinder we could only get 8 newtons from it. The second one we only could generate 71 newtons, and the third one we could generate 292 newtons. Okay, so the larger your cylinder, the higher the force. Okay, so always remember that as well as a basic principle with pneumatics. Okay, so if we look at the next slide here, there we go. Now you guys can make some notes. If you have questions, please ask as well. I'm going to draw some circuits using these symbols, so please stay with me and make notes if you do not know them. Okay, so on the left-hand side, we have the detailed air service unit symbol. So basically, it tells you exactly what you have inside the air service unit. Okay, so there we have a filter, and then we have our regulator and gauge, and our lubricator. So this is actually the simplified symbol for an air service unit. It states exactly the same that we have on the left-hand side, but in a simpler form. And this is actually the reason why we have a simplified symbol is because just to save time when we're actually drawing circuits. Okay, so on the left-hand side you have the filter, which is the same as the filter here. In the middle we have the gauge, which represents the gauge and the regulator. And on the right-hand side we have a lubricator and a lubricator. So there we go. So both of them, they mean exactly the same thing, but this one is just this symbol on the right is just a simplified symbol, and the symbol on the left is your detailed symbol. So obviously the detailed is used when you actually add more modules into this air service unit, so that you can actually clearly see what is inside your air service unit. But if you have a normal air service unit, which is either a filter and regulator or filter regulator and air lubricator, oil lubricator, then you can use this simplified symbol. But this is detailed. If you add more modules into your air service unit, then you would add more of the symbols. So this is the filter, this is our regulator with a gauge, and this is our lubricator. Remember, if you come for the basic pneumatics course, we will go through this again and in more detail as well. Okay, so then we also are going to have a look at some cylinders today. We are basically going to look at the single acting cylinders. So single acting cylinders normally have a spring in the front area, and it will return because of the spring force pushing against the cylinder, moving it backwards to reach position. A double acting cylinder, you can see, has got 2 ports. The single acting only has got 1 port. So if I apply pressure here in the back, it's going to move forward. The cylinder rod will move forward and overcome the spring tension. Once I remove the air from the back, the spring will push the cylinder back to its original position. On the double acting cylinder, we can see we have 2 ports. So if I apply pressure to the back, the cylinder would move to the front. If I apply pressure to the front, the cylinder would move to the back. Okay, so just to make that a little bit more clearer so that you guys can understand, let me quickly get another simulation here, just to make it easy to see, because I know the mechanical guys, they like to see to believe. They like to see to believe. Okay, so let me quickly bring you double acting cylinder. There's a double acting cylinder. Okay, so from the back, if I put apply pressure from the back, the cylinder would move forward. If I apply pressure to the front of the cylinder would move back. Okay, so that's our double acting cylinder. Let me quickly see if I find I have a single acting here for you as well. Okay, here we go. Our single acting cylinder. You can see there's a spring in the front, and that's keeping the cylinder in the retracted position. Okay, so now if I apply pressure, the pressure in the back of the cylinder would overcome the spring tension in the front, and it would move the rod to the front. If I remove the air, the cylinder would move, the cylinder's spring would return it to its retracted position. Okay, fantastic. So this is our single acting cylinder, only has one port. The double acting cylinder has two ports. You can see one and another. Perfect. Okay, good. Then there are also other types of double acting cylinders available in industry. I'm not going to go into detail into these now, but the two we're going to be using today are the single acting and the double acting cylinders. Okay, so we will be using these two today, just to build some few circuits and to demonstrate what you can expect to see in the courses as well. Okay, fantastic. So the double acting cylinder, this is all the double acting cylinder, but you can see now more has been added to our symbols. Okay, so it's the same symbol, but there's some added detail. So if we can see here on the left hand side, there's a little rectangle there. That means we have cushioning in one direction. Cushioning is something that we use to extend the life of a cylinder so that it can last longer. It is not speed control. I know there's a lot of guys that believes it's speed control. Is not speed control. It is to extend the life of the cylinder. Okay. In this case, the symbol only shows us it is in one direction only. It's only on the one side of a cylinder. This bottom one you can see it's on both sides of the cylinder. But the top one here and the second one is only got cushioning on one side of a cylinder. This arrow here means adjustable. So that means we can actually adjust the cushioning of the cylinder, how hard, how big, how strong the cylinders, the cushioning should be, so that the cylinder actually retracts to its original position. And that's not, but it's adjustable. So that arrow means it's adjustable. This one is adjustable, but in both directions. We have cushioning in the front and in the back of the cylinder. Okay, so let me quickly see if I have a cushioning simulation for you. Is there any questions at the moment? Hannes, have we received any anything in the chat yet while I'm looking for my cushioning here?
Charles, we had a question from Olusegun. He can just post again. He asked if when it comes back to the air preparation, why we should still make use of filters if we do already have water separators in the front. So I've answered the question, but anybody can just respond if they don't understand, please.
Okay, good. Okay, if there's another question, please post it so that we can also have a look at it. But the filters, they do two things. Basically, it removes the dirt and it also captures the moisture not to pass through. The condensate separator is not a filter, it is a condensation separator. It removes the water but not the dirt. Okay, so every single component has a unique feature and a unique job to perform within the system. Okay, just to give you guys an overview of the cushioning that we have here, what I've been talking about now. If we look at this here, the cushioning is only on the left-hand side. Here's the cushioning on the left and on the right. Okay, so this cylinder here actually has cushioning in the back, and it also has cushioning in the front. Okay, so here we can see here's some screws. There's a screw there that I can adjust. This side, the screw has been adjusted. This side, the screw has not been adjusted. So let's quickly have a look at what the cushioning looks like. So the air comes from the back. In the front, you create an air cushion. So it means that the cylinder does not slam into the front and create damage or impact damage to the cylinder body itself. But now look, we did not set the cushioning in the back. So let's return the cylinder and see what it does this time. You see, there we go. We got impact damage that's created because it slams into the back. So you will have impact damage. So that's why we would use cushioning in our cylinders as to create a cushion, an air cushion, so that you can have an smooth movement of the cylinder moving forward and back in a retracted position if you have cushioning on both ends. Okay, fantastic. So this is just air cushioning. We also do talk about it in the basics again, and we also talk about a bit more details regarding that. So please join us on the basic course. Okay, here we go. So then we also have another type of actuator.
Sorry,
Yes,
Shaul. I see there's another question from Ganiu. Ganiu, if you can just unmute yourself. You're welcome to ask a question. Can you hear us, Ganiu?
Okay.
Ganiu, can you hear us? Okay, Shaul, thank you.
Okay, guys, please don't be scared to talk. We like an interactive webinar, so please keep it moving and keep talking to us. Okay, let me just, here we go. Okay, so we are still on the double acting cylinder with adjustable cushioning at both ends. That was the last one that we spoke about now. And if we look at the next one, the rotary actuators. So mostly in pneumatics, what you would use, would use either pneumatic rotary actuators or linear actuators. The actuator is actually the component that does the work. And in this case, these are cylinders, and these are either motors, air motors, or they are limited to rotation. So at the bottom, you can see this one. This symbol means it is limited, it's got limited travel, but it has rotation in both directions because there's two arrows inside. And that's placed on the inside here. If you look at the first one here at the top, these three are air motors. This, because there's only one arrow, it tells me it's only in one direction that air can flow. Okay, and it only turns in one direction. The second one, we have an arrow again with the little triangle, which means it's in one direction and it's adjustable. The capacity is adjustable. Okay, then the third one, we can see we have two arrows, and with two arrows, triangles, and an arrow there as well. So that means it's adjustable capacity, but in both directions. And then the last one, like I already said, is limited travel. And this one, we won't be working with these today. But we will definitely be working with the double acting cylinders and the single acting cylinders that I'm going to show you. And we're going to play with that a bit. Okay, then we also have exhaust ports. Okay, exhaust port is what you would usually have this on a valve, because we use the compressed air to do the work. After the work has been performed, the air should be released again. So to get it out of the system, we need to exhaust it back to atmosphere. Okay, so if we see just a little arrow, like little triangle like this, that means it's an exhaust port on a valve. If we have a line with a triangle, that means we have an exhaust port which is threaded. So it means I can take out this this exhaust here, and I can replace it with a silencer. I can turn this in here. But when we start drawing on a fluid sim, our drawing package, I will show you that, and so that it makes a bit more sense. Then the next thing also you need to remember is when you make line connections, to show that the line is connected, it means you're using a T-piece in this case, and that means you can connect 3 pipes to one node or one point, and that means you need to put a dot. If the lines do not have a dot, that means if there's no dot here, it means the lines would be crossing one another. But if there is a dot there, the lines are not crossing, they are connected together using a T-piece or other type of component. Okay, so here we can see the lines are crossing. If they don't just cross and there's no dot, it means they are not connected. They are just crossing one another. Okay, then obviously most people would know this symbol. This is just a pressure gauge. And then also we have a visual indicator for pneumatics that is also available, but people are moving more towards the electrical indications now these days, and have been moving towards it for a long time. Okay, then we also have a check valve. A check valve, another name for a check valve, is actually a one-way valve. So if we, in the pneumatic, the basic pneumatic course, you will also be using, we will also be mentioning these and some other types of valves as well. So you can see here, if the air comes from the left, it will push the ball away from this corner here, and that means the air can pass the ball to the right-hand side. So the air will be able to flow from left, pass the ball to the right. If the air comes in from the right-hand side, it's going to push against the ball is going to block that corner there, and the air cannot pass through. So this is a one-way valve. Air can only pass from left to right, but not back from right to left. Okay, then on the next one we have here is actually the same. It's also a one-way valve, but we added a spring. All that means is that we need to reach a certain pressure before this ball actually will start to push backwards to allow air to pass through from left to right. Then we also have the next valve, which is a shuttle valve or an OR function. This is one of the valves that you will be using in the basic pneumatic course. But just to give you a quick example of what it actually does and how it works, I'm going to quickly play you a simulation just to show you practically, mechanically, what it looks like and how it operates. Let me just move my screens here. There we go. Okay, just an OR valve, just to show you, if we get a signal from the right-hand side, it will pass through to the output. If there is a signal coming from the left-hand side, it will pass out to the output. Okay, and if you have two signals, the one with the highest pressure would pass through, the one with the lowest pressure would not. Okay, so that is with our OR valve, or our OR function, also called the shuttle valve. Okay, that is the OR function. If we look at the next symbol, just to also talk about the next symbol, we got the two pressure valve, which is an AND function, which is also called an AND valve. Okay, and if we look at the AND valve, how that operates, also, by the way, we're going to be using this as well in our basic pneumatic course, and there's a few circuits that you will be building using them. Okay, the AND valve basically needs two inputs before you can have an output. So this is our valve. If we get one signal from the right-hand side, it's blocked. If we get one signal from the left-hand side, it's blocked. If we get two signals from both sides, then one of the signals will pass through and the other signal will be blocked. So in other words, for this valve to work, we need to be able to get an output. Okay, so two inputs to get an output. Okay, that is our AND valve. So one signal only would not allow output. Two inputs would allow an output. Okay, and that we also use in the basic pneumatics course, as well as this quick exhaust valve. So there will be instances in pneumatics where you would like to move your cylinder faster than the normal speeds that it returns or moves forward. For that reason, we would use a quick exhaust valve, and that quick exhaust valve would exhaust all the air in the cylinder much quicker and faster to the atmosphere, so that your cylinder can get rid of the air faster, and that your cylinder would move at a faster rate. That means you might be able to save some production time on your machine, and time means money. So that's good for the boss. Okay, so if we look at the next few symbols, we can also see there's something called flow control valves, and in this case we got the normal flow control valve and a one-way flow control valve. And we won't be using these ones today. There's quite a lot of information about these, what you should do, what you should not do, and what you might be able to do within limitations. Okay, so but in the basic course we also do go through all of that information. Okay, so flow control, basically what we do as a flow control is we want to limit the flow to our cylinder, and by doing that we're actually decreasing the speed. So by decreasing the flow of the air to our cylinder, we decrease the speed. Okay, so if we look at the second one here, actually what it means, it tells us it's in a one-way flow control. So in one direction, the flow would be controlled, but in the other direction, it would bypass. It would bypass the flow control valve. So in one direction, you would have slow movement, but in the opposite direction, you would bypass the flow control and you would move at normal rates or normal speeds. Okay, that is the flow control valves, some of the flow control valves. So looking at valve construction, something also to remember is what is a valve made up of. It's got a few parts. It's made up, it's put together to actually construct a valve. And the first one is the valve body itself. Okay, so in this case, I'm going to still explain this to you, but we will have a look at it. But this is a 5 two-way valve. Okay, and the 5 two-way valve, you can see there are 5 ports. Okay, and you can see there are 2 positions, one on the left and one on the right. So there's 2 squares, that means 2 positions, 5 ports. So 1, 2, 3, 4, 5 ports, and 2 positions, 2 squares. Okay, so you will have the valve body for the 5 two-way valve, for instance, as an example, and then you would also have seals. The seals would actually create chambers before each port. So these are the ports. This is 1, 2, 3, 4, 5. It's the same ports that you see here. Okay, this is a symbol for the actual valve. Okay, so then you would have the seals, and then you would also have a spool. This part is the only part in the valve that actually moves and makes a change, so that the air can change direction. And in this case, if it's a 5 two-way, it would change between 1 to 2, sending the air from 1 to 2 or 1 to 5, exhausting 2 to 3 or 4 to 5, depending on the direction that your spool moves to. Okay, then you also have controls, which is number 12 and number 14, which most people do not know. They just think it's a number, but 14 actually tells me I'm going to connect. If I put pressure on this side, on the left-hand side here, I'm going to connect number 1 to 4. If I put pressure on number 12 here, I'm going to connect on number 1 to 2. So that's actually what 12 and 14 means. It's not 12 and 14, but it tells me 1 connects to 4 and 1 connects to 2. That's actually what it means. Okay, so I'm sure you guys have already learned something today. Okay, then there's also a lot of other things that a lot of ways you can actually actuate your valves. Okay, on the left-hand side, we have all the manual types, all the manual methods that you can actuate your valve. So in general, you would use this symbol. That means it can actually be any of these. It's just a general symbol. But if it's a push button, you want to be specific, then you can use these other symbols specifically to state exactly what you are using. Okay, but this is just a general manual actuation symbol. Okay, then secondly, we have for the mechanics, for the mechanical actuation, we normally use a spring return as far as a return on a valve. So once the air disappears on the left-hand side, for instance, the spring would return it on the right-hand side. I will play you some simulations now just to make this clear. Then also what you might have is a mechanical pin. So you need a mechanical actuation or mechanical contact, actual contact from the cylinder to push against the pin to open or close your valve. The same as the roller. You might have a roller which might be on a roller limit switch or limit valve, and that should open or close your valve. And if you're doing electric or you're going to sit with us on the electro-pneumatic course, then this is one of the things that you will also be using. It is a solenoid, and then there are special types of solenoids as well available. Okay, then this is just a basic symbol for pneumatic actuation. So this is to show that if I apply pressure to this side, then it's going to send pressure to my valve here. But we will have a look at that quickly. Okay, so let me show you some of these valves, just so that it makes a bit more sense, so that you can see what I'm actually illustrating here. We look at the 5 two-way, and it's got an air spring, or a spring return. There you go, spring return, not a spring return, mechanical spring. So there's our mechanical spring, and here's 14. 14 means we're going to connect 1 to number 4. Okay, 12 is the spring. There's no port there because the spring will do the work. It will move the cylinder, the spool to its original position. Okay, so if we look here, I apply pressure to 14, it pushes the spool to the right, it overcomes the spring tension, and I'm connecting 1 to 4. Like we said, 14, 1 to 4, it's connecting 1 to 4. It exhausts number 2 to 3. Okay, so like I already told you as well, only the spool moves. It's not the whole valve that moves, it's the inside of the valve that moves left and right. So let me just release the air, and there you can see the spring takes over, and which is number 12, and it connects number 1 to 2. So air will flow from 1 to 2. If I apply pressure to 14, I connect pressure from 1 to 4, port number 1 to number 4. Okay, there we go. That is just to give you an explanation of what we are talking about at the moment. And let me just see if I have another valve here, just without any springs. A normal 5 two-way valve. There we go. Okay, so from the left 14, I'm going to connect number 1 to 4. I connect 1 to 4, but I exhaust 2 to 3. Okay, if I give a signal to number 12 and I take it away from 14, let's see what happens. I connect number 1 to 2 because it's 12, and I connect 4 to 5. So 4 exhausts to number 5, and pressure is applied from number 1 to 2. So as a general rule that we usually say that number 1 is your pressure, number 2 and 4 is your working lines, number 12 and 14 would be your signal, your pilot control in this case, and then number 3 and 5 would be your exhausts. Okay, so 1 is pressure, 2 and 4 is working lines, 3 and 5 is exhaust, and 12 and 14 would be the control. Okay, there we go. And that is basically how you can look at a valve and what the valve consists of. Okay, so if we look at the next slide, just to also help you a little bit, and if for some guys, if you have a pen and paper with you, you can make some notes. I know there's a lot of information we can give you, but we are a bit limited on time today. And but number 1 here, you can see we always look at the number of ports. So we look at the number of ports. Let me bring in a valve again. Then we can have a look and just compare it to what we see here. Okay, so here's a valve. How many ports do we see? Number 1. How many ports? It's 1, 2, 3, 4, 5. So that means 5 ports. How many positions do we have? Okay, it's either the spring's position to push it into the left-hand side, or if I give a signal to 14, it will push it to the right-hand side. So let's just do it again. There's one position, and there's another position. So there's one position and another position. So there's 2 positions here on this valve. Okay, so we have 5 ports and 2 positions. That means a 5 two-way valve. A 5 two-way valve. What is the condition of this valve? We will look at that as well when we look at our circuit, when we start designing. But in this case, this valve is a directional control valve. It's not normally open or normally closed, but it is a directional control. Because if we had to connect this to a cylinder, it would either move the cylinder to the front to extend, or bring it back to retract. Okay, so next thing we need to look at is method of actuation. How do I actuate this valve? How do I get it to change the position? It is by means of direct pneumatic actuation. So I'm bringing in air. Remember, pneuma means air, okay? Pneumatic, that's where it comes from. Pneuma, pneumatics, okay? So pneuma means air, and then when the air comes in, air will actuate my valve. So it's direct pneumatic actuation. So there we go. So if the air comes in, I actuate my valve. If I let go of the air, my air is actuated by the spring. So that is a spring return, which is the method of reset. So the method of reset here is the spring return. Number 6 here, the last thing to remember is the port size. Okay, this is important when you have to replace a valve or when you have to place a new order. You need to make sure that you replace it with the correct valve with the correct port size. Okay, so that your flow does not change. You need to make sure the port sizes are still correct so that you maintain the integrity of your flow. Okay, so that's it. So these are the six steps to name a valve. So if we go through them, so 5 ports, 2 positions. Condition of action. Condition is a directional control valve. The method of actuation is direct pneumatic actuation. Method of reset is a spring return. And the port size you will have to measure in real life. Okay, this is just a simulation, so I can't really tell you a port size here. So if you had to give it a name, you would say it's a 5 two-way valve, directional control, direct pneumatic actuation with a spring return. That is the full name for the valve. And if you talk like that, then you sound like a pro. So I would recommend you try doing that and you follow these rules. We do go over these things again, or these steps, when you actually do the basic pneumatics course with us. Okay, and then, so let's have a look at some of the circuits, just to have a look at some of the components that we're going to look at today, so that we can discuss them. Okay, so I'm going to bring in my drawing program. Here's a drawing program. This is called Fluid Sim. Okay, on Friday, we actually will be running this Fluid Sim. There's also an introduction, so that when you come and do the basic pneumatic course or any of the other courses that we actually offer, then you will have to draw circuits on FluidSim, our drawing package. So basically, once you register for the and you pay for the course to come to join us, and then we're going to be sending you this package for free with a 3-month license, so that you can actually join us in class and you can do some practical exercises. Okay, so this is our library. So what we're going to work with here, you can see is pneumatic. There's hydraulics. So there's a kind of a whole bunch of things that you can look at and work with. But in this case, we're just going to work with pneumatics. So first things first, we're going to get some cylinders. Okay, so you can see there are many cylinders to choose from and many different types available, and it depends on what you're going to use and what is the application that you're going to use it for. Okay, but for our circuits, we're going to try and keep it simple, straightforward, and we're going to build some different circuits and we're going to see what they do. Okay, so in other words, what other thing we also need for this circuit, for these circuits to operate properly, is we need a supply. Okay, and where does the supply come from? From a compressor. The compressor should compress the air so that we can use the compressed air to do the work, okay, on our cylinder. So we need to go and fetch a compressor. Then we also need an air service unit. Okay, the air service unit, like I already showed you earlier on that live video of mine, the live feed, is that you need to make sure you have a filter, a regulator, and in this case, that's all we have. We do not have a lubricator. Okay, this is the simplified symbol to make drawing easier. Okay, so here we can connect our compressor to our air service unit. The compressor will supply the air, the compressed air, to the air service unit. The air service unit would clean the air, and then the output of this of the air service unit would go into your system of control. Okay, so usually if we look at this system here, okay, this is now a single acting cylinder, and if I connect this directly to the air service unit, you will see once I start to simulate, we will have something happening. Just see, there we go. You see, there we go. So the cylinder moves forward, and that's it. No control. Okay, there's no control. We cannot control it. But unless we actually go and get ourselves a directional control valve. Okay, so there are many different types of control valves available that you actually can drag in and bring in, and it depends again on your application. What do you want to do? Okay, so there's 3 different valves. So let's try the first valve. This is a two-way valve, and we're going to add it into our circuit. Let's give it some extra actuation. Let's work on the actuation method and also this return. So let's give it a spring to return, and let's actuate it by a push button. Okay, so there we go. So let's see if this valve would work with a single acting cylinder. Let's try it. Let's see. Okay, if I push the button, okay, that's just something. Okay, here we go. If I push the button, the cylinder extends, but if I let go, it still stays there. The question is why? Okay, the answer to that question is because the air is still stuck in the back of the cylinder. It does not go anywhere. It's still there. So you built the pressure in the back of the cylinder, and it's still overcoming the spring tension, and the cylinder stays in the forward in an extended position. You cannot get it back. Look, there's no way to get it back. So in that case, in this case, actually, it tells you that's the incorrect valve to use. Okay, so let's go and get ourselves another valve. Okay, so if we had to use this valve, let's see this valve. Okay, so in this valve, what do we see? We have a number 1, 2, and 3. On this valve, we only had number 1 and 2. So on this valve, we had a two-way valve. Okay, 2 ports and 2 positions, but we only had 2 ports. So that means number 1 is usually pressure. Number 2 is your working line. There was no exhaust, no number 3. Okay, but this one actually has a number 3. You can see we're already connecting the line of the back of the cylinder to an exhaust. So like I told you, I'm going to show you here. You can go and pick your exhaust. So here's a normal exhaust. Here's an exhaust with a thread, or you can go and add some silencers on your valve. Okay, so let's say we just put a normal exhaust there, which is threaded, and let's give it the same components that we just had. Okay, so let's go and add.
How's it now?
Hello? Is there someone with a question? Hello? Hello? No one. Okay, then let's also give it a push button again. Okay, so we have a push button actuated with a spring return. Okay, there we go. Okay, so if we simulate now, what would happen? Let's have a look. Okay, so we have supplied air and it's been pressurized. I push the button, I let the air flow to the back of the cylinder and the cylinder extends. It overcomes the spring and the cylinder extends. Okay, but if I let go of this valve, what would happen now? Ah, there we go. The air is exhausting to the exhaust number 3, port number 3. Okay, so the air can get out again. That means the spring can return the cylinder to its retracted position. Okay, so let me play it again. I push the button, I open the line from the pressure line to the working line going to the cylinder. If I let go of the valve button, I actually connect the back of the cylinder. The air can flow to exhaust, which is on port number 3. Okay, so this looks like a very good valve to use. It looks like it's going to make this one makes the most sense so far. Let's go and get another valve and let's put this valve in here. Let's see what this valve would do. Okay, so let's sorry, let me just remove. This must go to number 1. Okay, so number 1 is always your your pressure line. Number 2 and 4 is working ports. Okay, then we have 3 and 5, which would be exhausts. So again, let's add some exhausts to our circuit here. Remember, guys, I'm just keeping it nice and simple so that you guys, if you have questions, you must ask, because not everybody is familiar with this technology yet. And if you do the basic pneumatic course, you would definitely be knowledgeable about it more than most people. Okay, good. So here we go. Okay, so what I had to do with number 2 here, because it didn't go anywhere, I had to block it. So if I take this away quickly, let me take it away and show you if I do not block it, what happens. Okay, without doing anything yet. So there you can see if I start it up now and simulate, you will see that the air passes through and I'm wasting air, compressed air, and I'm just blowing it out into atmosphere because 2 is open. Okay, so that means the air is just going to be wasted. Okay, and compressed air costs money. The compressor is working hard. It's costing money. It costs electricity to keep it running, to actually build up a pressure in the line. So we need to block number 2 so that we can actually build up pressure. Okay, so if I simulate it now after I blocked it, you will see that the pressure can actually build up. Okay, there we go. You can see we have a dark blue line here. That means it's pressurized and we have full pressure now. Okay, so now let's go on with the valve and we add more actuation and reset to the valve. And let's do that quickly. So again, the same thing as we've done before. We put in a spring return, we add a spring return and a push button. There we go. Okay, so let's see if this works. Okay, let's have a look. I push the button now. Would the cylinder move? Yes, I'm connecting 1 to 4. So the cylinder can move forward. If I let go, the spring returns the valve to its original position. And you can see the back of the cylinder, all the air exhausts to atmosphere. Okay, there we go. And if I do that, there we go. Okay, fantastic. Okay, any questions, guys? You guys must ask questions. So I need to have some questions here. If you want to think about these valves or know more about them, now is the time to ask, because the time flies and when you're having fun. So you need to ask questions if you have any. Please ask. Okay. So here we have a double acting cylinder now. And now you can see we do not have just 1 port. We actually have 2 ports. So obviously the circuit would have to look a bit different than the previous one we had now. Okay, so now let's design a circuit for this cylinder. Okay, so now we need more than 1 valve, obviously. Okay, so let's say we're going to use 2 of these. Can we use 2 of these? I wonder. Okay, so let's do that. And there we go. Okay, so let's put this in and see if we can use 2 valves to make the cylinder operate. Okay, let's simulate. Okay, here we go. We have pressure on both sides. If I put pressure to the back, it moves to the front. But it doesn't even meet. I'm struggling to get to the front there. Okay, let me close. Oh, okay, no. Okay, now we have a problem, because you can see that we actually we've pushed in pressurized air into the back line here, and now that pressure is maintained because I'm blocking it. Okay, the air cannot come out. The air goes nowhere. So even if I open it, the air still pushes into the space. So that pressure is maintained. Now, what if I push this one? I put more pressure on the opposite side as well, the same pressure. So it means it's pressure against pressure, the same pressure on both sides. So that means my cylinder cannot move anywhere. I need to remove some of the air in the cylinder to actually move some to either one direction. So let's change the valve type. We can remove that one, and we bring in 2 of these. Okay, so here's 1 valve, and if I take another one, and there we go. Now we have 2 valves. Let's see if this operates, if this works better. Okay, so air pressurizing both valves at the same time. If I push this button, I allow air to pass through to the back of the cylinder. The cylinder moves forward. It pushes my product into place. The air in the front, it can exhaust. Fantastic, this works. Okay, let me let go of that. Okay, we now let go of the button. I also release the air in the back. That's fantastic. So in other words, if I actually apply air to the front, pressure to the front here, I should be able to see movement to the back. Yes, there we go. And again, if I let go of the button, I exhaust all the air to the exhaust. Fantastic. Okay, does that make sense, guys? Anyone? Did everybody see everything? Okay, I'm just going to take this and make it a bit more practical. I'm going to show you a simulation of what we've done in the first circuit. So for the single acting cylinder, this is basically, in reality, if I had to cut my valve open and I had to cut my cylinder open, this is what it would look like. Okay, so now at the moment, I'm in this position. 2 is being exhausted to number 3. 3 is our exhaust. Number 1 is our pressure port. Okay, 3 is the exhaust port. Number 1 is exhaust pressure port. So pressure here, exhaust here. Spring tension from the right side, push button from the left-hand side. Okay, I have a single acting cylinder. There's a spring in the front of the cylinder, and there's no spring in the back, obviously. Okay, so let's push the button. Okay, there we go. So we push the button. We connect number 1 to 2. There we go. We connected 1 to 2. We move the spool to the right-hand side, and the air can pass from 1 to 2 into our cylinder, overcoming the spring tension in the front, and the cylinder moves to the front. Okay, that means it extended. This is the first circuit we've done now. Okay, so now once we let go of the button, we block the pressure port and we connect number 2 to 3. So all the air in the back of the cylinder would exhaust through number 3 to the atmosphere. Okay, I'll play it 2 more times, or just so that you guys can get a grip on it. There you go. And there we go. Okay, that was easy. Any questions on the single acting cylinder, guys, on this little circuit that we've done here, put together? Any questions? No one? No questions. Okay, fantastic. You guys are clever, eh? So let's go for the other circuit. Let's go and have a look at another circuit. But let's first try another option here that we can add to this double acting cylinder. We only have 1 more valve that we can try to see if that one actually operates as well. Let's see if we can replace these 2 valves with 1 valve to make it a simpler circuit. Okay, so I'm going to remove this, and remove this, and here we go. Okay, so one of the working ports goes to the front of the cylinder, the other port goes to the back of the cylinder. Then we only have one port left, and that means that is the supply pressure. There we go. That's a new circuit. Okay, so this is now a 5 two-way. Previously, we've used 2 3 two-ways. Okay, now we're using a 5 two-way. So now we have 5 ports. And we also gave it a push button to actuate and a mechanical spring to return. So let's play it, simulate, and see what it does. Okay, fantastic. The air passes to the front and the cylinder is waiting in the rear position. Okay, so once I push the button, it can extend. I connect port number 1 to port number 4, and that means the air passes through 1 to 4 to the cylinder to move forward. The front of the cylinder is automatically exhausted to number 3. If I let go of the button here, the spring will return the valve, and there we go. It pushes it back. So 1 is now connected to 2, and the air passes through the valve to the front of the cylinder, bring the cylinder back. The air in the back of the cylinder can exhaust at number, in at 4 and out at 5 to atmosphere. Okay, there we go. Another small circuit. Another one bites the dust. Fantastic. Okay, guys, I want to show you another circuit, but are there any questions before I go on? Because I know it's all new, it might be new to you or not. Maybe you just seen it at work inside a factory or workshop, and maybe now you get to see the inside workings. Okay, so for this valve, this is actually the simulation for that valve, the 5 two-way, and our double acting cylinder. Like I said, we connected the working lines number 2 to the front of the cylinder and 4 to the back of the cylinder. We have our button on the left-hand side here and our spring on the right-hand side. Okay, so 1 is our pressure, number 3 and 5 is exhausts to the atmosphere. Okay, number 1 comes from the compressor and air service unit. Okay, so let's play it again. There we can see the position changed and the cylinder moved forward as the air moved from the number 1 to 4 to fill the back of the cylinder. The cylinder moved forward, extended, and the air in the front came out, and it exhausted through from number 2 to 3, where the exhaust is. So the air went out back to atmosphere. Okay, if I return the spring return, I connect 1 to 2, so I pressurize the front of the cylinder. The air enters the front of the cylinder moves backwards. The air in the back of the cylinder were exhausted through to number 5, because number 3 and 5, remember, they are the exhausts. Number 1 is your pressure. Number 2 and 4 is your working lines. They are working lines. Okay, so this is a great idea. We only have one valve for two positions, and we only have one button that we can use for 2 positions. But if we wanted to be a bit more manual and not bringing it back automatically, we could go to the button and give it to the valve with the button on the one side, remove the spring, and give it another button on the opposite side. So there we go. Now let's see what happens now. Fantastic. Okay, so the air went to the front of the cylinder retracted. It's still in a retracted position. It's waiting there. Okay, I have a button on the right-hand side and I have a button on the left-hand side. Okay, now because there are no spring on this valve, we call it a memory valve, because the valve will remember where it was the last time when you actually actuated it into a certain position. There's nothing that will return it to its original position. There's no spring. Okay, so this is called a memory valve. So let's push the one button on the left and see what happens. And there we go. Okay, it extends and it's waiting there. You see, it's a memory valve. It's waiting. It's waiting for you to tell it to come back and to return. Okay, if I push the other button, there we go. We change the direction again. Okay, fantastic. Okay, guys, so that is just the basics I wanted to show you about some of the cylinders and some of the valves. You need an air service unit and a compressor. Okay, so your compressor supplies the compressed air. It goes to the air service unit for cleaning purposes, and then the clean air goes to your system, passes through your cylinder, through your valve to your cylinder. Okay, and remember we use these cylinders to do work. Okay, because they instead of you pushing something in place and taking it back out or something like that, or putting a component in by hand, then the cylinder could do it on your behalf. Okay, so there we go. So this is just yes.
Is it possible for you just to explain the internal cushioning of the cylinders again, if you've got a simulation there? The PPV, please.
Quickly see if
it was
I
a
have
question from Jason Marie.
Okay, I'll play it again. Thanks for the question. I enjoy questions. Okay.
Charles, well, okay, do you have it?
Yeah, I do have it. I have a cushioning here. Okay, I'm going to bring it in now. Here we go. Okay, so what was the question? Remember, not speed control. Cushioning is not speed control. Okay, go for it. Question?
Just the explanation. Just if you can just go through the simulation again.
Just to review it.
Yes, please.
Okay, guys. So this is a double acting cylinder again. We have a port in the back. We have a port in the front, and depending on where we bring in the air, that would move the cylinder either to the front position or to the retracted position. So either extend or retract. Okay, so if we bring in air from the back, you see, the air comes in here, it passes past that, and it goes into here, it fills the chamber, and it moves the cylinder forward. Okay, but let me play it again. Okay, but as it goes forward, you will see there's a pressure buildup in front here because the air must squeeze through this area here to get out. Okay, so the air must squeeze past the screw. There's the cushioning screw. So that you have set on your cylinder to actually get out of the cylinder again. If you don't get all the air out here, the cylinder will get stuck in a position. It would not reach the end position because you have built up pressure to overcome. To build the back pressure to fight against the pressure coming in. Okay, so if you have to let the air out in the front position so that your cylinder can get to the front position. Okay, and obviously if you do not turn in your screw, you will see the air just freely flows into the cylinder of the front of the cylinder chamber, and it will smash into the back because there's no cushioning set. Okay, it's not speed control. You will see there's a cushioning sleeve. This is a cushioning sleeve. There's a cushioning sleeve. Once this part makes contact with your cushioning seal, then only your cushioning starts, not while it's moving. Remember, this is just a simulation. It's a very short cylinder, this one. And you can now think it is speed control. It's not. Okay, because this part, the rod can be extremely long. And this is just right at the ends. When your cylinder reaches the front, almost at the end, and when it reaches at the back, almost at the end. So this is a very short rod we have here, but it's just for simulation purposes. Okay, so let's go do it again. Going back, impact damage. Okay, going forward, cushioning. An air cushion, high pressure, being developed in the front so that the cylinder moves slowly forward. Okay, I hope that answers the question, guys. If it doesn't, please tell me so that I can.
Yes, no, thanks. Thank you, Charles. Jason said that it answers his question. There's just one question that I answered earlier as well. The question from Olusegun was, why is there consistent moisture in the compressed air despite having all these elements in air treatment plant? So I explained to them that as the air gets compressed, it builds up heat because of the compression, and because of the temperature of the air, there is more vapor, water in the air in vapor form. But as the air leaves the compressor, the air cools down, and the vapor then condensates. So there's condensate forming, and that is why you would like your dew point of the air, the dew point temperature, to be as low as possible, so that the air does not reach that dew point temperature in the normal ambient temperature. But it's very difficult to do that unless you've got very, very effective coolers. So normally there is some condensate forming, and that is why you would want to, before your application, have filters to get rid of all available water. So Olusegun, I hope that answers your question better. Charles, if there's anything else you want to add there?
Yeah, you just remember that the compression and the release of the air happens extremely quickly. So that's why there will definitely be condensation developing. There's so many revolutions that happens within a compressor, thousands of revolutions. So it's very quick. Then therefore there will be some condensation developing. Yeah. Okay. Any other questions from anyone? Anyone? Okay.
Yes, guys, we've been. It is 3:30. We set the meeting until 4 o'clock, but yeah. So please, if there are any other questions, I think the guys are leaving because we've reached our time limit that the meeting was set for. Let me just switch on my camera so that you can at least see who you're talking to. Let me just see. I think there's another question.
Okay.
Sorry, let me just see who wants to ask that question. Olusegun, I'm just gonna unmute you so that you can. Olusegun, can you unmute yourself and just ask the question, please? Charles, he says that the usual problem they face in the factory is moisture in the compressed air. What can we do to correct this?
Well, I think first thing first is a sales engineer should come and have a look, do a visit there, and then see what he can normally look at, what he can find, just as a overall overview of the factory first of all. And then I'll just quickly put my other slide on again, and this is just to give him some tips here. Let's quickly see here. I go back to another slide.
Olusegun, while Charles is looking for the slide, like we explained, there is an increase in the temperature of the air when it gets compressed. So therefore, you will have vapor or water as in vapor form as it comes out of the compressor because the air is still warm. So down the line, you will probably have an air cooler, which will cool down the air, which will then have the water condensating, and then you can get rid of that water. But if you don't have a water cooler or air cooler, as the air cools down later on in the line, there will be some condensation, and you will have to get rid of that water by means of either water separators or filter regulators. So that is a common problem, and you have to obviously install the correct components to get rid of that water. There's Charles is showing you something, so you can just have a look there as well.
Okay, so you need to make sure you have a cooler after your compressor. You also need to make sure that you have a dryer. If you have a dryer or you can afford a dryer, then please get a dryer as well, especially if you are in pharmaceutical or FMCG, fast moving consumer goods, or in a very important, what you call it, very precise factory where precision is key. Okay, then you need to also, then obviously in the class of air would be different. So that means you would need a lot more protection and ways to get rid of air, the moisture in the air. Okay, then also the other thing also to remember is you need to have a receiver. Make sure the inlet and the outlet are on different levels. The outlet should be higher than the inlet so that all the condensation can get trapped at the bottom and be drained here. You can see there, number 5 is a drain. So your receiver itself You must make sure the inlet and the outlet is not close, and they don't look at one another in this side and out that side. It must be higher. You make sure it's higher or away, furthest away from the inlet, and make sure there's baffles maybe inside if they are closer. Okay, so make sure of those type of things, as well as liquid. If you look at this piping that I have here, there's a loop at the top. Most of you guys, most of the factories, they just put it straight down. That is a big problem, because now all your moisture in that main line will just drop down. You will go to your feed-off point, okay, where you're going to connect your machine, and that's not what you should do. The line should go up with the U piece, and then come down. So that means the moisture cannot get up. Moisture don't move up, moves down. Okay, moist air is heavier. Okay, so the dry air is lighter. So we need to get the dry air to pass through and go to your outputs, the points where you get your air from, your takeoff points. And so you need to make sure you have these loops. And I'm sure you guys don't have it. I'm sure. That's probably one of the problems. And then also the main line, it should be sloped so that the air can the moisture always runs to a certain point where it can be drained. Okay, so you need to make sure there must be a slope. The piping should not be straight, 100% straight. You should have a slope between 1 to 2% of sloping. Okay, so those are things, small things that you need to look at as well. So the design of the distribution system, that might be part of your problem, or maybe maybe you need a larger receiver that could help catch more moisture. Yes, you have a question?
Charles, I see there's another question from Sunday. Sunday, you unmuted, so you're welcome to ask your question.
I just want to ask that most time we have condensate in our compressor. Does it mean that the dryer is not effective? I just want to know what can cause the problem.
We also need to make sure if it's a dryer that you have, you must make sure that you have the correct dryer. There's about 5 to 6 dryers. Yeah, so you need to make sure. I can quickly look for some slide that I can show you about the dryers, just to help you see something. Then I'll have to look for it. But yes, you need to have the correct dryer for the correct type of industry. And for that, it's good to get a sales engineer out so that he can have a look at what you have and make recommendations on what you should get. But the moisture is a big problem, and the design and the distribution system is usually already a big problem, part of the problem. And then it's obviously, if it starts here and you do not cool it to the correct dew point, maintain the temperature at dew point temperature, then it will also have problems. So there's a lot of things can cause more moisture in the system than just one answer. One size does not fit all on pneumatics.
Yeah.
Does it answer
I
the question?
think it's very important what Charles said now. I think it's important to get the sales engineer or someone out to your factory just to make sure that the design is correct. Because also you can have your filters could be too big. And if the airflow through the filter is not high enough, so you've got a line, let's say perhaps you've got a 1/4 inch line, but your air filter is actually a 2-inch design or a 1-inch design. That means that the airflow through the filter will take place, but the air speed inside your filter will not be enough, which will then have the effect that the centrifugal force of the air will not be enough because of the air speed. That's not enough, and then you will not be able to get rid of the water. So there's a lot of factors that you should have to take into account when you've got water in your air lines, and how to get rid of them. So the best way is to get into contact with a sales engineer or distributor and let them assist you with that.
All right, thank you.
Okay, any other questions? Hannes, I just want to show Yeah, just want to show him some dryers, that there are different types of dryers available. Just see it's loading. Okay, it seems the PowerPoint does not want to open now. Okay, are there any other questions while I'm looking for that? Trying to open my other PowerPoint presentation. Okay, there we go. Okay, just to show you guys, there are different dryers, and they're all different types of dryers, and you need to know your type of dryer, and you need to make sure they are correct. You see here, so depending on which class of air you have, okay, it tells you the temperature, the dew point temperature that you should maintain, and how much airflow you should expect from a certain type of dryer. So this is just a little table just to help you decide on what type of dryer you have. So if you have a dryer, please make sure your dryer suits the application. It suits the application for what temperature you're going to run it at, the dew point, and how much airflow you would like through the system. So you can see the membrane there is got the least airflow, but it's from +10 to -40 degrees Celsius, the dew point. Okay, so it depends on your system and your application. You really have to look into more detail to choose the correct dryer and make sure it's appropriate for your application. Okay, and I also just want to show you, because there are different classes of air. Let me see if I can show you this. Okay, different classes of air. There you can see. Yeah, this one. Okay, there we can see. Okay, so class one. Class one, you can see the dust size is the filter size should be 0.1 microns, and that is the amount of dust you should expect, 0.1 per cube meter, and residual dust. So for residual water, you need to maintain a -70 degrees Celsius to make sure that you reach the minimum limit to actually have the correct air cleanliness for class number one, but that's hectic. Now, normal workshop classes are number 6 and 7. Okay, usually 6 for some more advanced workshops, but for pharmaceutical and food stuff, number 1 is many times followed. They aim to get to number 1, even though it depends on your type of equipment that you use. Okay, and then obviously the oil, how much oil you're going to allow in the air, into the air as well. So the lower the class number gets, the more stricter you get. So class 6 and 7, they are the least strict, you can see there, and it gets tougher as you get to class number 1. Okay. So any other questions, guys? Nothing?
Guys, thank you very much. Charles, it doesn't seem as if there are any more questions coming up. We will be posting the webinar on our Festo website under past webinars. So if you have missed it, or you weren't able to attend the whole webinar, or you've got people that you want to show it to, you can have a go and have a look there. But if there's no more questions, guys, thank you very much for attending. Thanks for participating. Please remember that we've got the other free webinars coming up tomorrow up to Friday as well. And we will be starting with our 4-day webinars, which is very interactive. You physically, like Charles mentioned, you physically do the exercises either on fluid sim for the basic pneumatics, electro-pneumatics, and basic hydraulic courses, and then for the PLC codices, you physically writing the programs on your own codices program. Just want to mention that the fluid sim software is the free license is available until end of June. So you will get the license if you attend any of the 4-day webinars to play with, to interact with, to design with, to do some simulations. And you're more than welcome to send me an email or anybody at Festo if you need any information on any of the courses. So thank you very much for attending. Charles, thank you for preparing and presenting. And good luck and good day to you all. Thank you.
Thank you.
Thank you, guys.
Appreciate it. Thank you.